Good morning, students. In the last class, we are discussing on the applications of dimensional analysis. So we completed two topics. So the third application is converting one system of unit into another system of unit. Right? So this one is the third application of the dimensional analysis. So that means converting one system of unit, right? So system of unit means combination or set of units. So that we call as the system of units. So we have four system of units: CGS, MKS, FPS, and SI system, right? So we are going to convert from SI system to FPS or SI system to CGS or from CGS to MKS system, right? So that is converting one system of a unit into another system of units, right? So that means we have one physical quantity. So that physical quantity that we can be expressed in CGS system, that also expressed in SI system, right? So for example, take the first one, right? So 1 Newton, that is equals to, so how many dynes or dash dyne, right? So here Newton is the SI unit in SI unit for force in SI system, right? So Newton another SI unit. So how became force? So same wise, dyne is also the SI unit in CGS system. So this is also for the CGS unit for the force, right? So force is a physical quantity. So this force we can be expressed or we can measure in Newton and also in dyne, right? So Newton is the SI unit to measure the force and dyne is the CGS, right? So this is the SI unit, right? So in the same way, dyne is also the unit. So in which system? That is in CGS system, right? ಸೊ ಎರಡು ಕೂಡ ನಮಗೆ ಎಸ್ ಐ ಯೂನಿಟ್ ಬಟ್ ಮೆಜರ್ ಮಾಡ್ಕೊಂತಾ ಇರೋದು ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಯಾವ್ದು ಫೋರ್ಸ್ ಬಟ್ ಯೂನಿಟ್ಸ್ ಯಾವ್ದ್ಯಾವ್ದ್ರಲ್ಲಿದೆ ಟೂ ಡಿಫರೆಂಟ್ ಸಿಸ್ಟಮ್ಸ್ ಅಲ್ಲಿ ಇದೆ, ರೈಟ್? ಸೊ ದಟ್ ಈಸ್ ಒಂದು ಎಸ್ ಐ ಯೂನಿಟ್ ಅಲ್ಲಿ ಇದೆ, ಇನ್ನೊಂದು ಸಿ ಜಿ ಎಸ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಇದೆ. ಸೊ ದಟ್ ಮೀನ್ಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕನ್ವರ್ಟ್ ಫ್ರಮ್ ಎಸ್ ಐ ಸಿಸ್ಟಮ್ ಟು ಸಿ ಜಿ ಎಸ್ ಸಿಸ್ಟಮ್ ಆರ್ ವಿ ಕ್ಯಾನ್ ಕನ್ವರ್ಟ್ ಫ್ರಮ್ ಸಿ ಜಿ ಎಸ್ ಸಿಸ್ಟಮ್ ಟು SI system, right? So general ಆಗಿ ಹೇಳ್ಬೇಕು ಅಂದ್ರೆ length can be measured in meter, centimeter, kilometer, right? So here meter is the SI unit for measuring the length, right? So same way centimeter is also the unit. So this is in CGS system. So in regular we can use, that is 1 centimeter is equals to 10 to the power minus 2 meter. So here I am converting from centimeter to meter, right? So in the same way here also we are going to convert SI unit into CGS system or from CGS system to SI unit, right? So here 1 Newton is equals to how much dyne? So here we need to find the value of dyne, right? So that is again by using dimensional analysis. By using dimensional analysis, we are going to convert one system of a unit into another system, right? So if any physical quantity we can express that in, right? So Q is a physical quantity. So this physical quantity that can be expressed by N into U, where N is the numerical value and U is the unit, right? So here we have two system of units for the same physical quantity. So that's why we can take that one as N1 U1, that is equals to into U2, right? So where N1 is the numerical value in first system or in one system, right? So same way into is the numerical value in second system, right? So next U1 is the unit in first system, right? So that can be expressed by the fundamental quantities m1, l1, t power 1. So a, b, c are the constants, right? So same wise u2 is the unit in second system. So that unit can be represented by M2, L2, T2. So again its code is ABC. Why it is ABC means, so dimensions of the same physical quantity on either side will be always remains same. Hence here we can take A, B and C. So in both the cases, right? So here if you observe here, so 1 Newton. So 1 is the numerical value, Newton is the unit. So this is in the first system, right? So same as N2, U2. So N2 is the numerical value of the second system, and U2 is the numerical value of the, sorry, U2 is the unit of the second system, right? So here this is in SI system. So Newton ಅನ್ನೋದು ನಮಗೆ SI ಸಿಸ್ಟಮ್ ಆಗಿದೆ, into U2 ಅನ್ನೋದು ಯಾವುದು ಇದೆ ಅಂದ್ರೆ ನಮಗೆ CGS system, right? So now writing the dimensions n1, m1 power a, l1 power b, t1 power c, right? That is equals to, that is replacing u1 by its dimensions, right? So same wise into m1, so m2 power a, l2 power b, t2 power c, right? So in the given data, one is the n1 value. So we know the n1 value and Newton, right? So here we need to represent in its measuring units, right? So we need to find the value of n2. So we don't know n2, right? So ಇಲ್ಲಿ ನಮಗೆ n2 ಗೊತ್ತಿಲ್ಲ. So n2 ನ first find out ಮಾಡ್ಕೋಬೇಕು, right? So writing this one n2, that is equals to n1, right? So this goes to the denominator, right? So m1 by m2, so it's whole power a, l1 by l2, it's power b, and t1 by t2, it's power c, right? Now replacing dimensions by its units, right? So unit n1 value ಗೊತ್ತಿದೆ 1. So Newton, its dimension is kg, unit is kg meter per second, right? So n2, that is equals to 1 into m1. So m1 is kg, that is in SI system, right? So that's why we are going to write kg divided by m2. So m2 is in the CGS system. So CGS system ಅಲ್ಲಿ ನಾವು mass ನ ಯಾವ ತರ represent ಮಾಡ್ಕೊಂತೀವಿ? CGS. So this is for length, this is for mass, and this for second, right? So centimeter, gram and second, right? So mass na ಯಾವ ತರ measure ಮಾಡ್ಕೊಂತೀವಿ ನಾವು? gram, right? So gm, so its power is 1. Why? Because Newton, that is kg meter per second. So ಎರಡು ಕಡೆ ನಮಗೆ ಪವರ್ಸ್ ಇರುತ್ತೆ, ಸೇಮ್ ಇರುತ್ತೆ. So a ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿದೆ ಇಲ್ಲಿ ನಮಗೆ 1, right? So next length na SI system ಅಲ್ಲಿ ಯಾವ ತರ ಮೆಜರ್ ಮಾಡ್ಕೊಂತೀವಿ ನಾವು? In meters, right? So that is m. The same length will measure in CGS system is centimeter, right? So centimeter, here b power is also 1. Why? Because meter, here power is 1, hence we are going to take the power, that is 1, right? So next for time, so in both the system time is measured by seconds, right? So SI system al kuda seconds, then CGS system al kuda seconds, right? So power is the kg meter per second square, right? So that is -2. So here in the numerator s and in the denominator s get cancels, right? So remaining these two. So N2 that is equals to either you can convert gram into kg or kg into gram, right? So 1 into this one is 1. So 1 kg is 1000 gram. So divided by gram. So power is 1, right? So keeping meter as it is, so in the denominator centimeter. So centimeter in terms of meters, that is 10 power minus 2 meters, right? So gram get cancels. So meter get cancels. So here 10 to the power of minus 2. If it goes to the numerator, it becomes 10 to the power plus 2, right? So 1000 we can write, that is 10 to the power of 3 into 10 to the power of 2, right? So that is equals to 10 to the power of 5. So ನಮಗೆ into value ಎಷ್ಟು ಬಂತು ಅಂದ್ರೆ 10 to the power of 5, right? So this we are substituting here, right? So 1 Newton that is equals to 10 to the power of 5 dynes, right? So 1 Newton ಗೆ ಎಷ್ಟು dynes ಇರುತ್ತೆ ಅಂದ್ರೆ 10 to the power of 5, that means 10,000 dynes, right? So this is similar to 1 centimeter is equals to 10 to the power of minus 2 meter, right? So ಇಲ್ಲಿ minus 2 ಇದೆ, so ಇಲ್ಲಿ ನಮಗೆ ಎಷ್ಟು ಬಂದಿದೆ 10 to the power of 5, right? So this is converting of one system of unit to another system. So here I am converting from SI system to CGS system, right? So simple is that by using the relation Q is equals to Nu. So Q is a physical quantity. So this physical quantity we can express by its numerical value along with its units. So Newton is the unit for the force. Force is a physical quantity. So the force na ನಾವು ಯಾವಾಗಲೂ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ ಅಂದ್ರೆ ನ್ಯೂಟನ್ ಇಂದನೂ ನಾವು ಮೆಜರ್ ಮಾಡ್ಕೊಂತೀವಿ, ಜೊತೆಗೆ ಡೈನ್ ಇಂದನೂ ನಾವು ಮೆಜರ್ ಮಾಡ್ಕೊಂತೀವಿ. ಸೊ ಎರಡು ಮೆಜರ್ ಮಾಡ್ತಾ ಇರೋದು ಸೇಮ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಆಗಿರೋದ್ರಿಂದ we can represent that one as n1 u1 that is equals to n2 u2. So n1 is the numerical value in first system and u1 is the numeric unit of the first system. n2 is the numerical value of the second system and u2 is the unit of the second system, right? So unit we can represent that in terms of m, l and t, that means in terms of fundamental quantities, right? So we know the SI unit of the Newton, that is kg meter per second square. So from this the value of a is equals to 1, b is equals to 1 and c is equals to minus 2. So why we are taken on both sides the same values means, so from the principle of homogeneity, so left side alli powers alli ಏನು value ಇರುತ್ತೋ, so right side ಅಲ್ಲಿ ಕೂಡ powers ಏನು ಇರಬೇಕು ನಮಗೆ same ಇರಬೇಕು, because both are the same units for the same physical quantity. So ಎರಡು ಯೂನಿಟ್ಸ್ ನಮಗೆ ಯಾವುದು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ಫೋರ್ಸ್ ಗೆ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡೋದ್ರಿಂದ ಅದರ ಪವರ್ಸ್ ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ ಸೇಮ್ ಇರುತ್ತೆ, right? So by substituting the values and simplifying we get the value of n2, right? So ಇದು important. So even generally 1 Newton is equals to how much dynes are there? That is equals to 10 power 5 dynes, right? So same 1 dyne that is equals to how much Newton, right? So here I am converting from CGS system into SI system. So dyne is the unit for force in CGS system and Newton is the unit for force in SI system. So ನಮಗೆ ಇಲ್ಲಿ 1 ನ್ಯೂಟನ್ ಗೆ ಎಷ್ಟು ಡೈನ್ ಅಂತ ಗೊತ್ತಾಯ್ತು. ಇವಾಗ 1 ಡೈನ್ ಗೆ ಎಷ್ಟು ನ್ಯೂಟನ್ ಅನ್ನೋದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. That is again by using the same dimensional applications of dimensional analysis, right? So here 1 dyne, 1 is the numerical value, so n1 value there. So dyne is the unit in the first system, right? So unit in the first system means, so up to here or so ಇಲ್ಲಿವರೆಗೂ ಎಲ್ಲದೂ ಸೇಮ್ ಇದೆ. So now here n1 u1 is in CGS system, n2 u2 is in SI system, right? So into that is equals to, so again this becomes n1 u1 into u2. So we are going to find the value of n2, right? So m1 again kg meter per second square. So m1 is the unit for mass in Cgs system, right? So mass ಗೆ ನಾವು Cgs system ಅಲ್ಲಿ ಯಾವುದರಲ್ಲಿ ಮೆಜರ್ ಮಾಡ್ಕೊಂತೀವಿ, that is in gram. So m2 that is in SI system, so ಯಾವುದರಲ್ಲಿ ನಾವು ಮೆಜರ್ ಮಾಡ್ಕೊಂತೀವಿ, that is in kg. Again its power is 1, right? So length in Cgs system centimeter, so in SI system meter, again its power is 1, right? So time, so ಎರಡರಲ್ಲೂ ನಮಗೆ seconds, c value ಏನಿರುತ್ತೆ -2. So here also second get cancels, right? So here also we can convert gram kg, that is 10 to the power of 3 gram, right? So centimeter 10 to the power of -2 meter divided by meter, its power is 1, right? So gram and meter get cancelled. So 10 to the power of 3 denominator is there, so numerator it becomes 10 to the power of -3 into 10 to the power of -2, so that is equals to 10 to the power of -5, right? So 1 dyne is equals to 10 to the power of -5 Newton. So up to here ನಮಗೆ ಎಲ್ಲದಕ್ಕೂ ಸೇಮ್ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ಮೆಥಡ್ ಇಲ್ಲಿವರೆಗೂ ಸೇಮ್ ಇರುತ್ತೆ. ನಾವು ತಗೊಳ್ತಾ ಇರೋ ಸಿಸ್ಟಮ್ ಬಗ್ಗೆ ಕನ್ಫರ್ಮ್ ಆಗಿ ಗೊತ್ತಿರಬೇಕು, ಯಾವ ಸಿಸ್ಟಮ್ ನ ತಗೊಳ್ತಾ ಇದೀನಿ ಅಂತ, ರೈಟ್? ಸೊ ನೆಕ್ಸ್ಟ್ ಥರ್ಡ್ ಭಾಗ 1 joule, that is equals to how much energy, right? So joule is the unit for work in SI system, and ERG is nothing but the energy. So energy is the unit for again work in Cgs system, right? So joule ಅನ್ನೋದು ನಮಗೆ SI system unit ಆಗಿದ್ದು, ಅಂದ್ರೆ energy ಅನ್ನೋದು ಕೂಡ ನಮಗೆ ಯಾವ್ದ್ರಲ್ಲಿ unit ಆಗಿರುತ್ತೆ, Cgs system, right? So now we can take n1 u1, that is in SI system, and n2 u2 in Cgs system, right? So joules ಗೆ another form ಯಾವ್ದಾದ್ರು represent ಮಾಡ್ಕೊಂತೀವಿ SI unit for joule. न्यूटन ಗೆ ಬರ್ಕೊಂಡು ಹೋಯ್ತಾನೆ kg meter per second square. So similar wise joule ಗೆ work done, force into displacement, right? That is kg meter square per second square. So here a value becomes 1, b value becomes 2, and c value becomes -2, right? So ಇಲ್ಲಿ powers a b c da, so a b c value ಏನಾಗುತ್ತೆ ನಮಗೆ, a is equals to 1, b is equals to 2, and c is equals to -2, right? So into is equals to 1 into, so first SI system ಆಗಿರೋದ್ರಿಂದ, so kg mass ನ ಯಾವ್ದ್ರಲ್ಲಿ ಮೆಜರ್ ಮಾಡ್ಕೊಂತೀವಿ, kg. So Cgs ಅಲ್ಲಿ gram, so power is 1, right? So length in SI system that we measure in meter, so in Cgs centimeter. So b value is to that 2, right? So next again time, it is in seconds, so here its value is -2, right? So seconds get cancels, into that is equals to, so 1 kg is 10 to the power of 3 grams divided by gram, right? So meter, that is 10 to the power of minus 2 meter whole square, right? So gram get cancelled, meter get cancelled, right? So remaining 10 to the power of 3 into, so 1 divided by 10 to the power of minus 2 whole square, that means 1 divided by 10 to the power of minus 4. So if it goes to the numerator, it becomes 10 to the power of plus 4, that is equals to 10 to the power 7. That is 4 plus 3, that is equals to 7. So 1 joule, that is equals to 10 to the power 7 energies, right? So ನಮಗೆ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಇರೋದು ಈ ಎರಡು, ರೈಟ್? ಸೊ ನ್ಯೂಟನ್ ಇಂಟು ಡೈನ್. ಸೊ ಡೈನ್ ಅನ್ನೋದು ಯಾವ್ದ್ರಲ್ಲಿ ಯೂನಿಟ್ ಅಂದ್ರೆ Cgs. ಸೊ ಅಗೇನ್ ಎನರ್ಜಿ ಅನ್ನೋದು ಯಾವ್ದು ಯೂನಿಟ್ ಅಂದ್ರೆ Cgs. ಯಾವ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಅಂದ್ರೆ Cgs ಸಿಸ್ಟಮ್, ರೈಟ್? ಸೊ ಅದ್ರ ವ್ಯಾಲ್ಯೂ ನೆನಪಿರಬೇಕು. 1 joule is equals to 10 to the power of 7 energies. So similarly you can try for fourth one, that is 1 energy that is equals to 10 to the power of minus 7 joules, right? ಸೊ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಸಿಸ್ಟಮ್ಸ್ ಇಂಟರ್ಚೇಂಜ್ ಆಗುತ್ತೆ. ಸೊ ಇಂಟರ್ಚೇಂಜ್ ಆದಾಗ ಇಲ್ಲಿ ವ್ಯಾಲ್ಯೂಸ್ ಕೂಡ ಏನಾಗುತ್ತೆ, ಇಂಟರ್ಚೇಂಜ್ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಪ್ಲಸ್ ಬರೋಕೆಲ್ಲ ಏನ್ ಬರುತ್ತೆ, ಮೈನಸ್ ಬರುತ್ತೆ, ರೈಟ್? ಸೊ ಇದನ್ನ ಟ್ರೈ ಮಾಡಿ. 1 ಎನರ್ಜಿ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು 10 ಪವರ್ minus 7 joules, right? So ಕೇಳಿದ್ರೆ ನಿಮಗೆ 3 marks ಅಲ್ಲಿ either they will ask for 1 newton or for 1 joule. So in Cgs system, so ಎರಡು ನಮಗೆ ಯಾವ್ದ್ರಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ Cgs system. ಇದು ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು, ಟೈಮ್ ಯಾವ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಯೂನಿಟ್ ನ ಮೆಜರ್ ಮಾಡ್ಕೊಳ್ತೀವಿ, ಎನರ್ಜಿನ ಯಾವ ಸಿಸ್ಟಮ್ ಆಫ್ ಯೂನಿಟ್ ಅಲ್ಲಿ ಮೆಜರ್ ಮಾಡ್ಕೊಳ್ತೀವಿ ಅಂತ, ರೈಟ್? So these are the applications of dimensional analysis. 3 applications ಇದೆ. So 3 applications ಅಲ್ಲಿ ಯಾವ್ದಾದ್ರು 2 marks ಗೆ ಕೇಳಬಹುದು, ಅಥವಾ ಜನರಲ್ ಆಗಿ applications ನ ನಿಮಗೆ 2 marks ಗೆ ಕೇಳಬಹುದು, ರೈಟ್? So next, limitations. Limitations of dimensional analysis. So first limitation is dimensionless constants cannot be determined by using dimensional analysis. Right? So that means in a physical quantity, that means we have derived the relation for the physical quantities. For example, time period of a simple pendulum, right? So that is equals to T is equals to 2 pi into root of L by G, right? So this is the physical relation, right? So here we can't able to determine the constant values by using the dimensional analysis. So ಇದನ್ನ ನಾವು derive ಮಾಡ್ಕೊಂಡಿದ್ವಿ relation by using dimensional analysis. So from that relation, that is we have written simply T is equals to K into root of L by G, right? So where K is a constant, so that value is 2 pi. So ಈ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿದೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನೋದನ್ನ ಡೈಮೆನ್ಷನಲ್ ಅನಾಲಿಸಿಸ್ ಅಲ್ಲಿ ನಾವು ಅದನ್ನ ಡಿಫೈನ್ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಬರೋದಿಲ್ಲ, ರೈಟ್. ಸೊ ದಟ್ ಒನ್ ಇಸ್ ದ ಫಸ್ಟ್ ಲಿಮಿಟೇಷನ್, ರೈಟ್. ಸೊ ಡೈಮೆನ್ಷನ್ಲೆಸ್ ಕಾನ್ಸ್ಟೆಂಟ್, ಸೊ ಇದನ್ನ ಡೈಮೆನ್ಷನ್ಲೆಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ಕರಿತೀವಿ, ಅಥವಾ ಇದನ್ನ ಸಿಂಪ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಕೆನಾಟ್ ಬಿ ಡಿಟರ್ಮೈನ್ಡ್ ಇನ್ ಅ ಫಿಸಿಕಲ್ ರಿಲೇಷನ್ ಬೈ ಯೂಸಿಂಗ್ ಡೈಮೆನ್ಷನಲ್ ಅನಾಲಿಸಿಸ್. ಸೊ ಈ ತರದ ವ್ಯಾಲ್ಯೂಸ್ ನ ನಾವು ಡಿಟರ್ಮೈನ್ ಮಾಡ್ಕೊಳಕ್ಕೆ ಬರಲ್ಲ. ಸೊ ಸೇಮ್ ವೈಸ್ ಇನ್ ದ ಎನರ್ಜಿ, ಸೊ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇಸ್ half m v square. So here also 1/2 is a dimensionless constant. So ಇದನ್ನ ನಾವು ಫೈಂಡ್ ಮಾಡ್ಕೊಳಕ್ಕೆ ಬರ್ತಾ ಇಲ್ಲ ಯಾವ ಮೆಥಡ್ ಅಲ್ಲಿ, dimensional analysis. So this is the limitation of the dimensional analysis, right. So next, so second one, by using dimensional analysis we cannot derive the relations of this type, right. So ಕೆಲವು type ಅಲ್ಲಿ ನಮಗೆ ರಿಲೇಷನ್ಸ್ ಇರುತ್ತೆ, ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್, ದಟ್ ಮೀನ್ಸ್ ಫಾರ್ಮುಲಾಸ್, so that we can derive by using the dimensional analysis, right. So such relations are, the first one is S is equals to ut plus half at square, right. So ನಮಗೆ equations of motion ಅಲ್ಲಿ ಯಾವುದು ಬರುತ್ತೆ ಅದು ಯಾವುದನ್ನು ಕೂಡ ನಾವು dimensional analysis ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಡಿರೈವ್ ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕೆ ಬರೋದಿಲ್ಲ, right. So v is equals to u plus at, right. So these type equations we cannot derive by using the dimensional analysis. So ಈ ಮೆಥಡ್ ಅಲ್ಲಿ ನಾವು dimensional analysis ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಈ ತರ equations ನ ನಮ್ಮ ಕೈಯಲ್ಲಿ ಡಿರೈವ್ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಆಗೋದಿಲ್ಲ. Only the physical quantities which containing maximum 3 fundamental quantities. So 3 fundamental quantities ಇದ್ರೆ ಮಾತ್ರ ನಾವು physical relation ನ ಡಿರೈವ್ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಬರುತ್ತೆ. So ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಆಯ್ತು ಅಂದ್ರೆ we can't able to derive the relations, right. So and the third one is it cannot explain the trigonometric function, exponential function, complex function in a physical quantity, right. So this one is the third limitation. So third limitation is it cannot explain the equations physical quantities relation ಅಲ್ಲಿ ನಮಗೆ ಯಾವುದೇ ತರದ trigonometric function ಅಥವಾ exponential function, complex function ಈ ತರದ್ದು ಇತ್ತು ಅಂದ್ರೆ ಅದನ್ನ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡೋದಕ್ಕೆ ಆಗೋದಿಲ್ಲ. That is one of the limitations or demerits of the dimensional analysis, right. For example, y is equals to a sin of omega t plus theta, right. So this is the physical relation. So ಇದನ್ನ wave equation ಅಂತಾನೂ ಕರೀತೀವಿ. So ನಿಮಗೆ next second volume ಅಲ್ಲಿ waves ನ ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಈ ಟಾಪಿಕ್ ಬರುತ್ತೆ, right. So this is the displacement equation of a wave. So ಇದನ್ನ ನಾವು wave equation ಅಂತ ಕರೀತೀವಿ. Here in this equation we have a trigonometric function, right. So ಈ ತರ trigonometric function ಇತ್ತು ಅಂದ್ರೆ ಕೂಡ dimensional analysis explain ಮಾಡೋದಕ್ಕೆ ಆಗೋದಿಲ್ಲ, right. So that is one of the demerits or limitations of the dimensional analysis, right. So these are the 3 limitations of the dimensional analysis. So ತುಂಬಾ ಇದಾವೆ, but so main basic ಇರೋದು ಈ 3 ಆಗಿರೋದ್ರಿಂದ so maximum in case exam ಅಲ್ಲಿ ಕೇಳಿದ್ರು 2 marks ಕೇಳಿದ್ರೆ either you can write any 2. So explanation ಕೂಡ ಇಲ್ಲ, just the statements ಬರೆದ್ರೆ ಕೂಡ enough, right. So these are the 3 limitations and 3 applications of dimensional analysis, right. So 3 applications ಮತ್ತೆ 3 limitations. So this is about the dimensions, right. So dimensions ಅಲ್ಲಿ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂದ್ರೆ applications, ಅದರ ಜೊತೆಗೆ physical quantity ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಳ್ತಾ ಇರೋದು dimensional formulas, right. So dimensional formulas ಅಥವಾ dimensional equations ಅಂತ ಏನ್ ಕರೀತೀವಿ ಅದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್, right. So that dimensions we are going to write by using the formulas. So formula based ಅಲ್ಲಿ ಇಟ್ಕೊಂಡು ಅಥವಾ SI ಯೂನಿಟ್ ಮೇಲೆ ನಾವೇನು ಬರ್ಕೊಂತೀವಿ ಡೈಮೆನ್ಷನ್ಸ್ ನ ಬರ್ಕೊಂತೀವಿ, right? So some physical quantities having the same dimensions, right? So ಎರಡು ಮೂರು physical quantities ಗೆ same dimensions ಇರುತ್ತೆ. So ಅದನ್ನ ನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. Physical quantities having same dimensions. Dimensions, physical quantity, right? So first one, m power 0, l power 0, t power minus 1, right? So that is for the frequency, angular frequency, angular velocity, right? Velocity gradient, decay constant. Right? So frequency, angular frequency. So frequency of angular frequency omega. So angular velocity, right? So that is omega delta S by t. So velocity gradient. So gradient is nothing but velocity changing with respect to distance, right? So aduna navenna velocity gradient anta karitivi. So and the last one is the decay constant, right? So all these physical quantities having the same dimensions, that is m l power 0 t power minus 1, right? So the second one is m l square t power minus 2, right? So m kg meter square per second square. So this is for the work, internal energy, kinetic energy, potential energy, so the next is torque. So torque is rotating force. So torque na navenanta kariತೀವಿ ಅಂದ್ರೆ rotating force. So next system of particles chapter ಬಂದ ಅಲ್ಲಿ ನಾವು torque na discuss ಮಾಡ್ತೀವಿ. So torque is also a force. So ಇದನ್ನ ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ rotating force. So ಇದ್ರ ಫಾರ್ಮುಲಾ ಏನಂದ್ರೆ force into perpendicular distance, right? So again force into distance. So that is again we having the same dimensions, right? So next, moment of force. So all these physical quantities having the same dimensions, that is m l square t power minus 2, right? So the third one is m l power minus 1 t power minus 2, right? So that is kg per meter second square. So here two terms denominator bರುತ್ತೆ kg per meter square second square. Sorry, kg per meter second square. So this is for pressure. So pressure is force acting per unit area, that is F divided by A, force by unit area. So pressure, stress, Young's modulus, bulk modulus, rigidity modulus, energy density, right? So stress again force acting per unit area. So pressure force acting per unit area. So pressure ಗೆ ಮತ್ತೆ stress ಗೆ ಒಂದು ಡಿಫರೆನ್ಸ್ ಏನು ಅಂದ್ರೆ ನಾರ್ಮಲ್ ಆಗಿ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದ್ರೆ ಅದನ್ನ ಪ್ರೆಷರ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ನಾರ್ಮಲ್ ಬಿಟ್ಟು ಯಾವುದಾದ್ರೂ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದ್ರೆ ಅದನ್ನ ನಾವು ಸ್ಟ್ರೆಸ್ ಅಂತ ಕರಿತೀವಿ, ರೈಟ್? ಸೊ ಅದನ್ನ ನೆಕ್ಸ್ಟ್ ಚಾಪ್ಟರ್ಸ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. So but we have to know the dimensions, right? So m l t power minus 1, right? So that is kg meter per second. So kg meter per second unit for momentum, right? So same that is for impulse. So impulse ಮತ್ತೆ momentum ಎರಡಕ್ಕೂ ಕೂಡ same unit ಇದೆ, that is kg meter per second, right? So the next fifth one is m0 l t power minus 2, right? So kg ila namge only meter per second square, right? So this is for the acceleration due to gravity, gravitational field intensity. Right. So yellow for the same dimension, right? So 6 m l t power minus 2. So kg meter per second square. That is the unit of force, right? Force, thrust, weight. The next is energy gradient. So gradient means with respect to distance. So energy with respect to distance na ನಾವು ಏನಂತ ಕರಿತೀವಿ energy gradient. So velocity with respect to distance na velocity gradient, right? So force, thrust, weight. So ಈ ಮೂರನ್ನು ಕೂಡ ನಾವು force ಅಂತಾನೆ ಕನ್ಸಿಡರ್ ಮಾಡೋದ್ರಿಂದ, right? So all these three having the same dimensions, that is m l t power minus 2, right? So energy gradient ಅಂದ್ರೆ energy by E by x. So velocity gradient ಅಂದ್ರೆ v by x. Next, seventh one, m l square t power minus 1, right? So kg meter square per second. That is for angular momentum, right? That is mvr, and for Planck's constant. So then we have m l0 t power minus 2. So this is for the surface tension and surface energy, right? So ninth is m0 l2 t power minus 2. Latent heat, gravitational potential. So the 10th m0, L0, T power minus 2, K power minus 1. So K is for Kelvin, right? So that is for the temperature. So temperature ke now T anta use ಮಾಡ್ತಿಲ್ಲ because time ge T use ಮಾಡಿರೋದ್ರಿಂದ. So K nothing but Kelvin is the unit for the temperature. So ಇಲ್ಲಿ K ನ use ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ಅಂದ್ರೆ temperature ಇರುತ್ತೆ, right? So that is for thermal capacity, gas constant, Boltzmann constant, and entropy. Almost ಇಷ್ಟು ನೀವು ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡ್ತೀರಾ, ರೈಟ್? ಸೊ ಡೈಮೆನ್ಷನ್ಸ್ ಏನಿರುತ್ತೆ ಅಂದ್ರೆ ಮಾಸ್ ಇರೋದಿಲ್ಲ, ಲೆಂತ್ ಇರೋದಿಲ್ಲ, ಓನ್ಲಿ ಟೈಮ್ ಮತ್ತೆ ಟೆಂಪರೇಚರ್ ಮತ್ತೆ ಟೈಮ್ ಗೆ ರಿಲೇಟ್ ಆಗಿರುತ್ತೆ. ಸೊ ದಟ್ ಇಸ್ ಥರ್ಮಲ್ ಕೆಪಾಸಿಟಿ, ಗ್ಯಾಸ್ ಕಾನ್ಸ್ಟೆಂಟ್, ಬೋಲ್ಟ್ಜ್ಮನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂಡ್ ಎಂಟ್ರೋಪಿ. ಸೊ ದ ಲಾಸ್ಟ್ ಒನ್ ಇಸ್ so 11th one. So ಇದು ಒಂದು ಸ್ವಲ್ಪ ಇಂಪಾರ್ಟೆಂಟ್ ನೆನಪಿರಬೇಕು, ರೈಟ್? ಸೊ ದಟ್ ಈಸ್ dimensions, that is physical quantity which does not contain dimension or dimensionless quantities. So ಅಲ್ಲಿ ನಮಗೆ m40, l40, t40. So that means ಇದು ಯಾವುದಕ್ಕೂ ಕೂಡ ನಮಗೆ dimensions ಇರೋದಿಲ್ಲ, ರೈಟ್? Dimensionless physical quantities. So write any one or two dimensionless physical quantities means we need to write. So that one is the strain. So in the next chapter we discuss quantity strain, refractive index, right? So second year we discuss quantity refractive index, relative density, relative density, relative permittivity, relative permeability, solid angle. So solid angle and normal plane angle, right? So these are the physical quantities which having no dimensions. That means ಅದಕ್ಕೆ ಯಾವುದೇ ತರದ್ದು dimensions ಇರೋದಿಲ್ಲ, right? So ಇದಕ್ಕೆ ಯೂನಿಟ್ ಇರುತ್ತೆ, ಅಂದ್ರೂ ಕೂಡ ನಮಗೆ dimensions ಇರಲ್ಲ, right? So plane angle it is represent, that is it is measured by the unit radians. So solid angles t radians. So ಇವೆರಡಕ್ಕೂ ಕೂಡ ಯೂನಿಟ್ಸ್ ಇದೆ, ಬಟ್ ನಮಗೆ ಡೈಮೆನ್ಷನ್ಸ್ ಇಲ್ಲ. ಸೊ ರಿಲೇಟಿವ್ ಪರ್ಮಿಯಾಬಿಲಿಟಿ, ರಿಲೇಟಿವ್ ಡೆನ್ಸಿಟಿ, ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್, ಸ್ಟ್ರೈನ್. ಸೊ ಇದು ಯಾವುದಕ್ಕೂ ಕೂಡ ನಮಗೆ ಯೂನಿಟ್ಸ್ ಇಲ್ಲ, ಸೊ ಡೈಮೆನ್ಷನ್ಸ್ ಇಲ್ಲ, ರೈಟ್? ಸೊ ಸಮ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಯೂನಿಟ್ಸ್ ಬಟ್ ನಾಟ್ ದ ಡೈಮೆನ್ಷನ್ಸ್. ಸೊ ಕೆಲವಕ್ಕೆ ಯೂನಿಟ್ಸ್ ಇರುತ್ತೆ ಬಟ್ ಡೈಮೆನ್ಷನ್ಸ್ ಇರಲ್ಲ, ಇನ್ ಕೆಲವಕ್ಕೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಯೂನಿಟ್ ಇರೋದಿಲ್ಲ, ಡೈಮೆನ್ಷನ್ಸ್ ಇರಲ್ಲ. ಸೊ ಅಂತದನ್ನ ನಾವು ಡೈಮೆನ್ಷನ್ಲೆಸ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್. ಸೊ ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ? ಕಾನ್ಸ್ಟೆಂಟ್ ಕ್ವಾಂಟಿಟೀಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಸ್ಟ್ರೈನ್ ಈಸ್ change in length by original length, right? So numerator ಕೂಡ length ಇರುತ್ತೆ, denominator ಕೂಡ length ಇರುತ್ತೆ. So length cancel ಆಯ್ತು ಅಂದ್ರೆ ಅಲ್ಲಿ ನಮಗೆ ಯಾವುದೇ ತರದ್ದು ಯೂನಿಟ್ ಸಿಗೋದಿಲ್ಲ, right? So strain. Next, refractive index. So this is a constant. So this value is n is equals to 1.5, that is for glass. So glass ke refractive index value ಇದೆ. So this value is a constant, that is the dimensionless constant. So ಇದಕ್ಕೆ ನ್ಯೂಮರಿಕಲ್ ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೆ, ಬಟ್ ಇದಕ್ಕೆ ಯಾವುದೇ ತರದ್ದು ಯೂನಿಟ್ ಇರೋದಿಲ್ಲ. ಸೊ ಯೂನಿಟ್ ಇಲ್ಲ ಅಂದ್ರೆ ಅದಕ್ಕೆ ನಮಗೆ ಡೈಮೆನ್ಷನ್ ಕೂಡ ಇರೋದಿಲ್ಲ, ರೈಟ್? ಸೊ ರಿಲೇಟಿವ್ ಡೆನ್ಸಿಟಿ. ಸೊ ರಿಲೇಟಿವ್ ಅಂತ ಹೇಳಿದ್ರೆ ಕಂಪೇರಿಂಗ್ ಒನ್ ಡೆನ್ಸಿಟಿ ವಿತ್ ದ ಅನದರ್ ಡೆನ್ಸಿಟಿ. ಸೊ ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲಿ ಕೂಡ ಡೆನ್ಸಿಟಿ ಇರುತ್ತೆ, ಡಿನೋಮಿನೇಟರ್ ಅಲ್ಲಿ ಕೂಡ ಡೆನ್ಸಿಟಿ ಇರುತ್ತೆ. ಸೊ ಎರಡು ಡೆನ್ಸಿಟೀಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗೋದ್ರಿಂದ ನಮಗೆ ರಿಲೇಟಿವ್ ಡೆನ್ಸಿಟಿ ಕೂಡ ಯಾವುದೇ ತರದ್ದು ಯೂನಿಟ್ ಇರೋಲ್ಲ. ಸೊ ಯೂನಿಟ್ ಇಲ್ಲ ಅಂದ್ರೆ ನಮಗೆ ಅಲ್ಲಿ ಯಾವುದೇ ತರದ್ದು ಡೈಮೆನ್ಷನ್ಸ್ ಇರೋಲ್ಲ. ಸೊ ಸೇಮ್ ವೈಸ್ ಪರ್ಮಿಟಿವಿಟಿ, permeability. So ಎಲ್ಲದಕ್ಕೂ ವ್ಯಾಲ್ಯೂಸ್ ಇದೆ, ಬಟ್ ರಿಲೇಟಿವ್ ಅಂತ ವರ್ಡ್ ಯೂಸ್ ಮಾಡಿದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ? ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಇದಕ್ಕೆ SI ಯೂನಿಟ್ ಇದೆ, ಜೊತೆಗೆ ಇದಕ್ಕೆ ಡೈಮೆನ್ಷನ್ ಕೂಡ ಇದೆ. ಬಟ್ ಇನ್ ಕೇಸ್ ಆಫ್ ರಿಲೇಟಿವ್ ಮೀನ್ಸ್, ಸೊ ರಿಲೇಟಿವ್ ನ್ಯೂಮರೇಟರ್ ಮತ್ತು ಡಿನೋಮಿನೇಟರ್ ಅಲ್ಲಿ ಸೇಮ್ ವ್ಯಾಲ್ಯೂಸ್ ಬರೋದ್ರಿಂದ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಸೊ SI ಯೂನಿಟ್ ಇರೋಲ್ಲ. ಸೊ ಸೇಮ್ again it comes under dimensionless physical quantity. So name any two or any three dimensionless physical quantity means you need to mention. So now ಈ ಇಯರ್ ಸ್ಟಡಿ ಮಾಡ್ತಿರೋದು ಸ್ಟ್ರೈನ್ ಜೊತೆಗೆ ರಿಲೇಟಿವ್ ಡೆನ್ಸಿಟಿ, ಸೊ ಸಾಲಿಡ್ ಆಂಗಲ್ ಅಂಡ್ ಪ್ಲೇನ್ ಆಂಗಲ್. ಸೊ ಪ್ಲೇನ್ ಆಂಗಲ್ ಮತ್ತೆ ಸಾಲಿಡ್ ಆಂಗಲ್ ನೀವು ಮ್ಯಾಥ್ಸ್ ಅಲ್ಲೇ ಸ್ಟಡಿ ಮಾಡ್ತೀರಾ. ಸೊ ಸ್ಟ್ರೈನ್ ನೆನಪಿರಬೇಕು, ಸ್ಟ್ರೈನ್ ಇಸ್ ಚೇಂಜ್ ಇನ್ ಲೆಂತ್ ಟು ದ ಒರಿಜಿನಲ್ ಲೆಂತ್, ರೈಟ್? ಸೊ ರಿಲೇಟಿವ್ ಡೆನ್ಸಿಟಿ ಮೀನ್ಸ್ density with respect to another density, aduna ನಾವು relative compare. So relative velocity study ಮಾಡೋದಲ್ಲ, so same wise, right? So comparing one velocity with the another velocity, right? So some other constant also we having both the numerical value along with its SI unit. For example, speed of light. So speed of light is a constant, right? So that value is c, that is equals to 3 into 10 power 8 meter per second, right? So c is a constant. So constant is that, but this constant having both the numerical value and SI unit, right? So dimensionless constants ಅಥವಾ dimensionless quantities ಅಂತ ಹೇಳಿದ ತಕ್ಷಣ ನಮಗೆ ಎಲ್ಲಾ ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ಕೂಡ ಡೈಮೆನ್ಷನ್ಲೆಸ್ ಆಗಿರೋದಿಲ್ಲ. ಸೊ ಕೆಲವಕ್ಕೆ ಡೈಮೆನ್ಷನ್ಸ್ ಇರುತ್ತೆ, ಕೆಲವಕ್ಕೆ ಯೂನಿಟ್ಸ್ ಇರೋದಿಲ್ಲ, ರೈಟ್? ಸೊ ಅದು ನಿಮಗೆ ಡಿಫರೆನ್ಸ್ ಗೊತ್ತಿರಬೇಕು. So next we will discuss on accuracy, precision and errors. So this is up to the dimensions. So dimensions illige complete ಆಯ್ತು. So next errors ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡೋಣ, right? Thank you.